So hopefully we can get a crit, you know where. Today we're presenting from staging. So if you haven't tried Recon, you can actually go at staging.getrecon.xyz and you can preview the staging version, which is the upcoming features. And today I'm gonna do kind of a demonstration around some of these tech that we're building. So I'm gonna share the mirror. If my screen breaks, you can still follow me on the mirror with a couple of ideas. But let's get started on staging. The main change that we're testing now is a update to the builder. And fundamentally, the builder has a lot of challenges. The biggest one will always be the constructor, especially making the constructor useful. So we can solve that, but that's going to be tied to using AST. And so until we start using AST, it's basically impossible to solve the constructor in a meaningful way. And AST is also useful to convert internal functions into harnesses that can be used. So that's where AST comes in. But in terms of the current improvement that we have, you'll note, if you're familiar with our UI, that we now have a dropdown that allows to change the mode. So this is the most basic demo ever of how Recon scaffolds your target functions, which is the part that always changes about the contracts that move the story. And by changing this mode, we can change them to effectively have the failure mode, which basically asserts failure at the end of every handler. This is really convenient for advanced usages because you may not know if some of your handlers are being called. And so this is a really quick and dirty way to verify that the coverage happens. We spoke about this in the previous office hours, and generally speaking, the main issue with this is that it breaks the story. It actually causes the revert scenario for all of these. So you don't necessarily want to use this too long, but to get started, this can be really good because now anytime the fuzzer finds a failure, it means that you actually found some inputs for which the fuzzer is able to progress and not revert. So that can be really convenient. And then the next mode that is cooking is called the catch mode, which effectively converts all of these statements into try catches, which means that instead of having to type all of this crap, you're gonna be able to have a try catch that verifies that your call is successful, and it's gonna set it up in this way. This is actually leading up to a more advanced setup, which is what we call differential fuzzing, which is the idea that you would actually have a try catch and you would capture all the values and you could potentially compare it against another implementation. And so I foresee that in a couple of weeks at most, we're going to be able to have differential fuzzing. And the reason why this is convenient, it's the start of something more convenient, is because you may need to test for a specific revert. You may remember me speaking about overflow checks. We're internally testing with the overflow check. And so over time, we should be able to support the ability of automatically generating harnesses that check for specific revert cases. Because obviously, a try catch doesn't necessarily help you as much as instead verifying that a function doesn't revert for overflow or doesn't revert for division by zero or doesn't revert for other compiler inserted panics that can be a lot more meaningful. But that said, this should help you, save some of that arm pain, and it should help you get your handlers to a bit better coverage. So this is the main change on the product, on the builder side. And then the next feature that I expect us to add is going to be what I call the demo. So fundamentally, a lot of people have actually used the builder. I think over 200 repos were built. So it's not like people haven't tried it. However, the sign up process is still a kind of a hurdle. So we will remove the sign up process with the downside that you're not going to be able to build an entire project. So if you sign up to Recon, you're going to be able to build an entire project with all the ABIs, etc. So this is basically possible only by building it locally, simply because you would have to paste every ABI manually. Whereas what we can do without login will be to have a box. Basically, we would have like a box somewhere here where you can drop one ABI for a single contract, and we're still able to scaffold the target functions for you without a sign up. So that's something that is also really convenient for my own workflow. So I think it's going to be really convenient for a lot of you to that end. And then middle to long term, we're going to be dealing with more internal stuff, like internal, basically converting libraries and scaffolding those, and ideally fixing the constructor. But that's kind of the I guess the premium aspect of the builder. This fundamentally saves you 5 to 25 to maybe a couple hours for every new project. So it really depends how many projects you do. In my case, when I'm trying to hack stuff, I end up building a lot of these. But if you're more on the blue side, you may only build it once. So the time saves are not going to be that extensive on this side, whereas they're going to be very interesting on the other side of what we're building, which is going to be improvement to the parsing. So I'm going to go on staging because that way I don't show you some really crazy alpha type result. But this is the jobs page for Recon. This is part of the Recon Pro side, which basically allows our customers to run invariant tests in the cloud, and they can also share the results. So they just click this button, and then this page becomes a shareable URL. I'm going to share it here in the chat for you guys to check it out. And fundamentally, the current status of the job page is a technical page, right? You have your logs, which is basically what the runner was doing, and then you have your coverage report, which will help you figure out the paths that were explored. So this is still more on the technician side, and our goal instead, and also our original vision with Recon, was tied to something closer to this, which was the idea that Recon will build you an exploit automatically. That was the main, and it still is the main direction for Recon. But fundamentally, to have Recon be able to determine what it was able to extract is still fairly far off from us, especially in lack of a more specialized template. Because if we had a template called, let's say, the Recon value extraction template, then I believe that we will be able to offer this experience, but it would also be more of an illusion where it would only work for our template. So that's why it's still not there, but at the same time, we're moving towards something closer to this. And so our next step for our job page will be to add the parsing tool, which you can access at tools/Medusa and tools/Echidna. These are our parsing tools. You basically just copy the logs, and then they parse whatever broken property you have. In this case, there's none. Let me see if I can find you a quick demo broken property. All the successful jobs here. No broken properties, but I guess I'll skip over that. But fundamentally, the process of debugging these broken properties always looks a little like this, where you have to either grab the corpus and run your critic tools to build you the POCs, or you grab the logs, you paste them here, and then you copy your code. And so the next improvement that is cooking is going to be the ability of having pranks, warps, and blocks. Ignore the wrap typo, it's going to be changed to warp. But fundamentally, this is going to make it so that when you scrape a Medusa or an Echidna log, you have access to all of those additional aspects that allow you to go faster from the log, which is something that is more of a technical tool. Like, nobody really cares about the logs. We want the POCs. And so we're trying to get you faster to that POC. And what we're gonna do very soon is we're gonna introduce the POC as part of the jobs page, which means that all of our customers will get a POC automatically generated for every single broken property in all of their jobs. And the goal that I have with that, on a purely selfish aspect, is that way you don't have to spend as much time writing the POCs for your bugs, for your bug reports, for your submissions, etc. You will have them automatically written, and they will already be part of the Recon job page, which means that you can literally link that, and it's gonna speed you up. And so to that end, another improvement that we're exploring, which is also tied to the properties, is going to be what I call the report mode. And I guess I'm gonna just draw it out. We don't have a design for this yet, but fundamentally, something that we're doing now is we're starting to discuss partnerships with other fuzzing companies or fuzzing teams. And so we offer them Recon as a tool that they can use. And so if you have your own little shop, do message me, and perhaps we can collaborate. And something we've noticed as we finished our own engagements, and we expect that other teams are also going to need as they finish their engagements, is that you have to write a report for the properties that you tested. And so what we're going to do is we're going to build a way to have the POC builder for the broken properties, but we're also just going to have a report generator for the properties that were tested. So you're going to have, prop name, perhaps a description. We're going to have to standardize that into a template. And then you're going to have the runs. And lastly, you're going to have a proof that it was actually run for how many cycles it was tested, 10 million tests, 100 million tests, 2 hours in this case, whatever the actual run was run, simply because that way we're, making it faster to, just get to feedback, basically. Just, send the report, send the POC, all of that stuff we want to automate so that it's gonna be faster. And the biggest aspect with this, especially if you've tried, because we have it for free at getrecon.xyz/tools/medusa or /echidna. They look the same, but they parse different outputs. If you haven't tried this, the main issue with this is really the pranking and the delays when you start to have a long sequence. So something that I'm looking into for a code that I'm reviewing is I'm basically trying to get a sequence for whatever broken property that I'm looking into. And many of these sequences, they tend to have like 10, 15 items. And so you can imagine that as you have that many items in your trace, now you have to paste and type this wrap 15 times. And so it gets really boring and really also really slow, really quickly. And so hopefully by adding this, we're gonna make it a lot faster to again focus on what matters, which is breaking properties and running the fuzzer. And then the last thing I wanna mention that is gonna be a quick improvement, I'm interested in your thoughts as well, is that we're going to introduce an echidna mode as one of the buttons for our echidna runner. And that's because echidna needs to be run in different modes. And at least from my experience, they're all very useful. We have the optimization mode, the assertion mode, the property mode, and then the exploration mode. And they're all useful. The least useful one seems to be the property mode. That's at least what other teams have been saying, is that because you have to separate assertions with properties, they basically never use the property mode and they write all of their properties as assertions. That's something you can see if you go on the Euler Vault Kit. It's an example of the work that Victor did. You can see in his handlers that basically you'll only find assertions. I guess I got the one that but you can see that everything has an assertion, because that way you can run all of your tests. But what I found through my own work is that you can also use echidna for optimization mode. And optimization mode can be extremely useful for evaluating MEV. This is something we're doing right now, and as well as evaluating conditions or damage. And so because of that, we're gonna introduce the mode button, because what's gonna happen is you're gonna be able to use your default echidna config, which may or may not have a mode, but by default, our runner will override the mode, which means that it's gonna be more convenient to use it. And so that way we're gonna basically realize kind of the vision for Recon V1, which means that you're gonna be able to automatically get all of your POCs. You're gonna be able to share them automatically. If you need an audit review, or if you shop, you're gonna get your report by default, which is convenient to everybody, because you know, who doesn't want a nicer recap page? And then lastly, we're gonna bring a few improvements to the runner and to the builder, so that you guys that you know, are not using Recon Pro, you still get the benefit. And at the same time, we can have a culture where differential fuzzing becomes a default. You can get it for free simply because we set up the builder to allow that. And so this is kind of what we got cooking so far, and what we're gonna be working on in the upcoming days when it comes to the product. And then the last thing we're working on, which I'm gonna do a separate office hours. I'm not sure if it's gonna be next week, but it's gonna be soon. It's gonna be ecosystem fuzzing, which is gonna be our first stab at writing already pre-written testers that you can just fork, so that you automatically get a bunch of stuff. For example, a token. Something we're researching will be having a single ERC20 that works with all STIF derivative tokens. So that way, if you need to test the behavior of WEF if, or of ST if, or of puffer if, or of O if, etc., you have a single token that works with all of those interfaces, and you can basically test it out in one go, which allows you to reason around those tokens in an easier way, and it allows to add them to your automated tests in an easier way. So that's gonna be kind of what you should expect from us. On one end, it's gonna be quick new improvements on the product side, and then the ecosystem fuzzing, which we're gonna be talking about in the next few weeks. And lastly, the last couple of things to tease are going to be the blast results. I have yet to, I guess I don't know when I can talk about those. I'm not sure if the report is out, but as soon as the report is out, I'll show you what I did for blast. which actually didn't yield me any severity, but it was interesting to show how I basically proved that they solved rebasing. And then another interesting bug that I can show you is going to be for curvents, which is actually a critical bug in how they priced LP pool, which again I need to I guess get approval before I can show them. So that's gonna be kind of it from me. If you guys have a few questions, let's chat a few minutes. Otherwise, that was a quick show of the things that are upcoming, and in the next few days you'll be able to also try them. If you want to try them out today, you can go to the staging version of the site. I'm gonna link it in the chat. And we made the staging public, so you're free to try out our upcoming features. And if you send us a bug report, we'll fix them before we ship it to prod. And we'll most likely ship these new modes very shortly, as they we actually have a decent architecture. So we had a question by Renzo. Provided values. How often do you bind your fuzz and provider values? Okay. So yeah, so let me think about it. Okay. So this is how I work. And you can see it literally here with the coverage report. So I generally try not to bind. So if you can get away with it, you would not bind at all. But what tends to happen is with some type of conditions, you basically end up creating more work for yourself. So if I can give you I guess a secret to something I was looking into, the interesting decision in this suite is that all of the tokens are both collateral and they're also borrowable. And because as you can see, they're just generic and they just, they get a random asset. Actually, they always set the same token. So what I'm trying to say is there's basically two ways to do an example of a borrow lending scenario. And one way will be that you define a token that is deposited and you define a token that is borrowed. And when you do that, your coverage is going to be a lot faster simply because you're removing all of the calls in which you set the same token to being both borrow and deposit, and there are basically no ops, or they're basically useless, not particularly meaningful scenarios. And so most of the times clamping is dictated by the fact that you need to get to a certain coverage fast enough. And so my advice is to always start with our builder output. Like you will literally just start with the most generic, most basic implementation. And perhaps you will test it out with the fail mode so that you can see that each of them are being hit at least once. And so that will be your starting point. But what tends to happen, especially let's look at the approve, where you can approve, an infinite amount of tokens for an infinite amount of addresses, is that it may not yield any interesting result. And so this line may never be hit in your experience because you run for only, 2 days and it never gets to coverage. And so when you find yourself in those scenarios, that's where you will clamp, and that way you save a lot of time. So that's kind of the gist of it. You will clamp until you're happy, and you will always try not to clamp too much. So the last piece of advice I can give you, see if I'm gonna leak, I guess I'm gonna leak too much if I do that. So the last piece of advice will be to do this, where let's say you're gonna clamp the approve function, but you also want to keep the bigger one. So what you will do is you will literally write a second function like clamped approve, and you will then call the approve below. So you will basically call the other one, but you will call it with some hard-coded value. And so that way you're still using the generic handler to give you the potentiality of the coverage, but at the same time you're also creating an handler that gives you faster coverage. So that's my 2 cents on clamping values. That tends to be the best way, because you don't want to bias so much that you're not gonna be able to get any coverage. Is ecosystem fuzzing like critic properties? You can say that it's kind of like critic properties, but the main difference will be that we're gonna do it for specific projects. So you can think of restaking setup where you need to test that. That's where we expect to do something, and then something like an AMM where we expect a lot of projects that build on top of AMMs to need the same type of tests. So that's the type of stuff that we're looking to serve, because by doing that we can not only give our expertise, but we can also make it so that all of those projects are a bit safer by default by checking against the most common bugs. So that's what we're going to be doing with ecosystem fuzzing. So we got the last question by Renzo was tied to what parts of the PC. I think the CPU is the most important one, and then in the future is going to be the GPU when EVM GPU becomes a thing. But once EVM GPU becomes a thing, you're all going to need to use Recon. So make sure to lock in that price early. Send us some customers, we'll give you a discount, because once it becomes GPU fuzzing and you need to run clusters of GPUs, it's gonna become more complex. But today, just buy a good PC or rent it out on whatever provider you want. Hetzner is the cheapest one, as far as I know. Christos asks, is it a good idea to introduce a random Boolean value in the handler functions and only clamp the desired value only half, or for example 3/4 of the time? So there's multiple aspects to this question. We explored most of them on the EBTC Oracle discussion. If you haven't watched our video on the EBTC Oracle, you should definitely check it out. But fundamentally, the way the EBTC Oracle started was something like if else for updating variables. And then something else they were doing was they had some sort of a multiplicative change. So what do I mean? An if-else scenario means that, let's say it's 0 or 1. It means that if it's 0, you're going to alter code X, and if it's 1, you're going to alter code Y. The problem with this type of logic is that now, anytime you go and you look at the coverage report, maybe you're going to see that all of the lines are green, but you don't necessarily know the ordering, or you don't necessarily know the preconditions, or you don't necessarily know how often they're being called. I guess you would argue they're called 50-50. But basically what I'm really saying is that you're making this more complex, where if you want a if-else, just put 2 handlers. Because that way, if you need to change one, you don't have to change the other. You're not creating this bad dry, like basically you're trying to be too smart with this dry stuff, and you actually end up creating more work that is meaningless. So just do 2 separate handlers in this case. Whereas the multiplicative change, the issue that you have is that now you created a fake constraint that makes it so that block A to block B to block C, they all have some sort of a ratio. So by creating this more clamped change, you actually made it so that if you have a fuzzer, normally the fuzzer, like this is going to be a probability distribution, you basically have a probability distribution that is equivalent for every value. Like every value is as likely as the other. Whereas once you add this type of clamps, now you're creating a scenario where you actually need a way more unlikely set of combination to get to the more interesting parts. And so that's what happened to the EBTC scenario. We missed like some edge case scenario of a 50% Oracle change because we had a multiplicative change that made it basically impossible to have that 50%. So my advice is that if you're gonna do this thing, just do what I showed here, where you basically are giving a 50% chance of having the clamped value, because the clamped value will call this one, and then you still have a 50% chance that it's gonna call the one that is not clamped. So that's my advice. Don't add the extra if-else logic. Literally just write a unclamped version and then a version that is clamped that will call the unclamped version. That way you only have to maintain the unclamped code, and the clamped code doesn't require any maintenance. Next question by Fork Dog. What are the main principles for building a template by a project types? I guess we don't really know, as in, I don't know what the answer is. I had one of our team members spend a lot of time on that, and I also have spent quite some time working in other aspects. So if I think about, for example, yield vaults, year 64626 vaults, for example, I can think about some specific common mistakes or some bugs that I have, you know, up my sleeve that I always check for, that have worked well for me. And so that's the type of stuff that I would add in a template. And then lastly, the main reason why you would even build a template is because you foresee a lot of people expanding on that same code. So the most basic example of the template will be the work by, you know, XD20 on, is it XD20 on Weird ERC20? DXO, but like you would look at something like this, and so you would argue that this is the first ecosystem fuzzing, because, but it's, you have to do it manually because they are telling you to test all of this stuff. So our contribution to the same cause would be to instead create a ERC20 with some sort of a, I don't know, a bytes input that, given the bytes that it receives, it changes its behavior. And then you just plug in your ERC20 and you can test all of the stuff. The issue with something like this is that we cannot give you any properties for this, because if we just give you the token, you have to write all of the properties. And so our way of doing the ecosystem fuzzing is, instead we're gonna look at a primitive. So what could be a primitive? Will be, let's say, Morpho from Morpho Labs. It could be the optimism fault proofs. It could be Eigenlayer, the staking contracts. And so we will take one of those, and then we will write all of the possible story for it, all of the state transitions that make it so that a slashing happen, a bond is paid, the admin moves the bond, the admin upgrades, the proof is valid, the proof is invalid. We basically will do all of that, so that if you build something on top of it, you're gonna get all of those state transitions for free, so that you can focus on writing your custom code and all of the underlying stuff is gonna work. Whereas if we did something like a critic-like properties, which will be something I will do for, let's say, for vaults, then we will simply write a bunch of automated tests. Stuff like, you know, deposit versus borrow, donate, can I move the PPFS, that type of stuff. And so we will be a bit more complete, but at the same time, it will just be a way to basically to, you know, find bugs through a bug bounty. Whereas on the ecosystem, we're basically looking to help projects that are building on top of primitives by having the primitive give you all of its possible states, so that you can test your own code against all of the possible states that come from integrating on a primitive. So that's kind of the logic, and we'll be sharing more as we finalize our first ecosystem fuzzing campaign. But if you do have a few more questions, I'm happy to answer them. Otherwise, that was kind of it from me. Thank you all for joining, and I'll see you next Thursday, hopefully with a good crit on the other contest.